What I want to talk about today, Sophia, is how older TVs worked. By older TVs, I mean the ones that had that big bump that stuck out the back, because that was the guts of the television. You probably still had those when you were little kids, and it's been over your lifetime that you've migrated to the current flat screen, thin TVs. What was going on inside here, Liam? Inside here, at the heart of every TV, was called a cathode ray tube, or a CRT. A cathode ray tube is basically an electron gun. It was a way to fire a beam of electrons. And from that, with a bit of cleverness, you could get television. So a CRT is a cathode ray tube. In the simplest cathode ray tube, a beam of electrons is accelerated by one set of plates and then deflected by another. It hits a fluorescent screen, which glows. This is a very, very basic side view of an old style black and white television. So a person would be sitting right here looking at this screen. How did it work? I'm going to zoom in. Don't draw everything that I'm drawing. I'll tell you when to draw stuff in. First of all, we need to get some electrons to go to the right. What we would do is we would charge this plate up negatively very, very strong. Why? Because like charges repel. So draw those in. Make that plate negative, please. Draw those in. And then I'm going to add a bunch more stuff. Don't draw this next bit. Electrons will be bubbling off all willy-nilly. We wanted to get a nice thin beam, so I didn't include it in this picture. Don't write this in, but we would have a negative plate right here, and we would have a negative plate right there, because like charges, it would push them towards the electrons towards the middle. We would probably have a bit of a positive plate right here to pull them to the right, and then we would just have a very, very thin slit. By doing that, you get a pretty straight beam of electrons. So don't draw in these or that. It's just going to clutter up the diagrams. Point is, Kevin, I now have a beam of electrons moving to the right. Now I get to the deflecting plates. Normally there's 4 plates, not 2. Here I have 2 plates that are set up horizontally. You would also have 2 plates that were set up vertically. I'll show you that in another picture. But like charges, unlike charges, as an electron gets through here, let me zoom out a little bit. As an electron passes through the plates, if we bump up the positive voltage, we might deflect it right to there. Bump up the positive voltage even more, might deflect it right to there. Reverse the plates or bump up the negative voltage. We reverse the plates, we could deflect the electron to there with an alternating current. On the inside of this screen right here, we have it painted with a phosphorescent paint, a paint that will glow when an electron hits it. So this person sitting in the chair would see a bunch of dots glowing. Do that quick enough, the person will see an image. Refresh it fast enough, the person will see a moving image. That's TV. There it is. So let's look at the mechanics of this in a little more detail. Oh, first of all, put your pencils down, look up. Professor LMNO, what was it called, Mr. Dueck? Professor Whoopi. Why can't I see Professor? There, right there.
But there's still something I don't understand, Mr. Whoopi. Oh, what's that? What?
So over on this end, it's receiving the signal either from Cablevision or from the old style through the air antennas. It's turning that into an electric signal, which is determining how fast and how many electrons are going to come out of here. Here's the deflection plates, and so what you're going to see is we can deflect electrons up or down. They hit the phosphorescent plate, they make the TV screen glow. Don't know what that is. Sorry?
The two picture into electrons. Oh, two turns the electrons into the picture. Precisely.
Now that's for black and white television. A full electron at maximum energy makes a white dot. No electron makes a black dot. By varying the speed of the electron, you can get a gray dot. So you could get black, white, or gray. And that worked 1930s, 1940s, 1950s. Then how did they do color? So color was a little bit different.
The monitor work. Signals from your computer.
So until about 15 years ago, the standard was RGB, red, blue, green. That's what you were getting for your color television. And by combining those, just like combining paint, your eyes would see the rest of the colors. So you had 3 electron guns.
These three colors will mix together to create all the colors.
Your eyes don't notice it, but you may have noticed in a video of a video screen, if someone's using their phone and there's a computer monitor in the background, you may have noticed the monitor tends to flicker. That's because the video camera is taking pictures at very close to the same rate as the monitor is rewriting its screen. And so you can notice a flicker as you do so.
Instead, the screen appears to be a steady, continuous, just as it does now.
So let's dive into this a little bit more. Here is a side view of a cathode ray tube and the front view of the screen. So again, we're imagining somebody is sitting right there. If any of you have ever seen an old black and white TV, Liam, when you first turned them on, you just got a big white dot dead center because they actually had to warm up for a while. So that's our initial position. When we turn the TV on, we're getting a big white dot right there in the middle. Suppose we make the upper deflecting plate positive. Will that deflect this dot to location A, B, C, D, or E? So let's visualize. We have the electron coming through. We've made this one positive. How will that deflect the electron? Up, down, left, or right relative to the viewer? So it's going to be deflected up. Is that going to hit in location A, B, C, D, or E on this picture? Yep. Sorry, A is the first one. I put the answer next to the wrong one. Now we also have a second set of plates. These ones can deflect it left or right. So what happens if we make the right plate positive? How will that deflect the electron? So we'll send it back to the middle first of all, and we'll make the right plate positive. Will that deflect it to A, B, C, D, or E? Gershon, like charges, unlike charges. So if we make this one here on the right positive, it's going to get attracted that way. Where will the electron end up relative to this viewer? A, B, C, D, or E? So we're starting here. Yep, what? Yes. Good. All right. What if we make the upper plate and the right plate positive? How will that deflect the electron, Kevin? Yes. And so I hope you can see by varying the voltage, by flipping the voltage if we need to, we can put an electron anywhere on the screen that we want. Let's take that a bit more. Now we're going to adjust the voltage. So instead of the electron beam hitting dead center, the electron beam is hitting here. Turn the page. Where will the dot end up? Choose from A, B, C, D, E, F, or G if we increase the deflecting voltage. So right now it's being deflected up a little bit. If we bump up the deflecting voltage, will that make it deflect more or less? So will that be A, B, C, D, E, F, or G? G. What if, get back to here, so it's hitting right here again. What if we reverse the polarity of the deflecting voltage? We make positive, negative, and negative, positive. Where will it get deflected to now? C. What if we increase the accelerating voltage? I'm going to scroll back. You can stay on your page. What if we have it come out of here faster? Do you think it's going to get deflected more or less than if it's going slower? So, where is it going to end up? A, B, C, D, E, F, or G? A. And again, my point, Liam, is you can see with a bit of cleverness, we can put an electron anywhere on that screen that we want. We can make any pixel glow that we want. It says explain your answer using principles of physics, like charges repel, but we're good with that. So in what way does this explain how an old style black and white TV works? 1 pixel or dot is hit at a time. By sweeping the Y voltage, we can move the beam up and down. So let's suppose we start right here. If we sweep up and then, you know what, Mr. Dueck? Come back. If we sweep up and then down, we can fill in one single line. Then we step the beam over a tiny bit by bumping up the left-right voltage a little bit. And so now we sweep up, we sweep down, we fill in that section. We keep bumping up that right-hand voltage, the right-hand deflecting voltage, then it goes, sweeps there, 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 there. And you slowly, well, quickly, fill in the image. And then, rather than start all the way over here, I think they just went backwards, forwards, backwards. Do that 60 times a second, your brain sees a picture, a moving image. Your brain doesn't notice the sweeping at all. So if we gradually add increments of the X voltage, moving it to the right, sweeping vertically, we will illuminate the entire screen. The TV signal turns the beam on or off as necessary. So the beam is sweeping the screen, but sometimes it won't fire an electron. Beam on is white dot, beam off is black dot, beam partially on, gray. In this manner, a picture is created. Although in actuality, we don't use parallel plates to deflect electrons, we use solenoids because the plates had to be lengthwise, which made the back stick out an awful lot. Solenoids could be put in vertically at right angles, and so it meant the back stuck out less. It got a little wider, but you had to be wide enough for the picture screen anyway, so that wasn't the big issue. So this is really a more modern cathode ray tube black and white TV. Want you to notice solenoid M, this vertical solenoid. If you use your right hand rule, you're either going to have a magnetic field pointing that way or this way. Which way would that deflect an electron? So all of you, right thumbs with the coming out of the page towards you. Let's use my screen. And let's pretend the magnetic field is pointing up. Which way would that deflect the electron? To the left? Or if the magnetic field was pointing down, to the, yeah, a vertical solenoid gives a horizontal deflection because of the right-hand rules. And this horizontal solenoid, if you do the same thing, if you realize the magnetic field's here are going to be in that direction. Out of the page, magnetic field that way. The horizontal solenoid gives you a down or gives you an up deflection. So solenoid M, vertical, can deflect left or right. Solenoid N, which is in itself horizontal, can deflect up or down. That's technically the end of the lesson, but I got a couple of cool videos to show you, but I need to pause the video here.